Okay, so today we're going to be practicing um, rectangular approximation. Okay, so these are the three practice problems at the end of our notes. So we're going to be working with a simple quadratic equation, basically x squared plus 2. Very similar to um, what we just did in the last example. Okay, so we're going to be finding the area under this curve using 6 subintervals. Okay, which means we're going to be using 6 rectangles. We're going to be finding the area under x squared plus 2 between 0 and 3. Okay, so that's what we're doing. So let's start with Rram. Okay, so we've chosen to draw 6 rectangles on this interval from 0 to 3 because we're doing 6 subintervals. So I've drawn in my 6 rectangles. So since we're using Rram, our rectangles are hitting on the right side of my function. Okay, so my first rectangle starts at 0, ends at 0.5. Since we are doing from 0 to 3 and we're dividing it up into 6 rectangles, each one of these rectangles has a width of 0.5. The height or the area of this is going to be determined by the height of it, and the height comes from my function. Okay, so the easiest way to do this is to start plugging in and finding the heights of each rectangle. So for the first one, I plug in 0.5 into my function. That gives me the height of 2.25. Then the next one, I find the height at 1, because this height right here is the y value at 1. And I keep going through and I find the heights of all of these rectangles. Okay, so my first rectangle has a height of 2.25, and then the second one is 3. So these are all the heights of them. Okay, so to make it easier on myself, because say I want to find my total area, it's going to be basically base 1 times height 1 plus base 2 times height 2 plus base 3 times height 3 plus blah 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 blah. But since in this case all of my bases are exactly the same, since base 1 and base 2 and base 3 are all 0.5, I can take out my base and basically add up all of my heights. So it's like factoring out, taking out my common base, since they're all the same, adding up my heights. So that's what I did. So I took all of these heights and I added them up. Then I can multiply my total height by the width of each one, which is 0.5, and that will give me my area. And my area is 17.375. Now this method of finding all of my heights, adding them together, and multiplying them by the common base only works if all of my rectangles have exactly the same base length. The width is exactly the same. So for instance, if I had different ones, if the first one was 0.5 and the second one was 0.6, it wouldn't work that way. I'd have to find each area individually. But since they all have the same, I can add up all the heights and then multiply by the common base. Okay? So the hardest part about doing rectangular approximation is figuring out, one, which approximation method am I doing? Am I doing Rram? Am I doing Lram? Am I doing Mram? And then making sure that when I draw my little picture, I know what it looks like so that I can start at the right spot. Because if I try to do Rram, I have to know that I'm starting at 0.5 and not 0. Okay? So speaking of Lram, my second example is Lram. Now it's the exact same function, exact same amount of rectangles. The only difference is, since I'm doing Lram, my rectangles hit on the left side. So you notice on the last one, my height came from the right side, but on this side, on this one, the heights come from the left side. So all of these heights come from the left side of the rectangle. So in the last one, where I started at here at 0.5, This one I'm going to start at 0. My first rectangle height comes when at 0. Okay, so I'm basically going to do the exact same thing I did on the last one. So I plug in 0 in my function. My height is 2. Plug in now 0.5. This should be the same number because I just did it from the last one. So basically all the rest of these numbers are the exact same values from my last one. Now, these are the height of my 6 rectangles. So just like the last time, I'm going to take all the heights and add them together. So my grand total of heights is 25.75. Now that's just the height. Since I want the area, I'm going to take the height times the base, which is 0.5 for each one. And I find my area is 12.875. Okay. So again, the difference here is that I'm just using rectangles that hit on the left side. And if you notice from basically here to here, this is the exact same thing from my Rram numbers. Okay, these are the same values. The difference, Lram started at 0 and Rram went all the way to 3. So there was another value after the 2.5. So I still have 1, 2, 3, 4, 5, 6 values here. The difference is that Lram started at 0, where Rram started at the 0.5 value. Okay, so we've done Rram, we've done Lram, so now let's do Mram. Okay, now we're still choosing to draw 6 rectangles from 0 to 3. Okay, and this is where it gets tricky. Because my values, or my rectangles, go from 0, and this is 0.5, in Mram, the height comes from the middle. So instead of using 0 or 0.5, halfway between 0 and 0.5 is 0.25. And then this one here is at 0.75. And this one right here is at 1.25. And this height right here comes from 1.75. So that's generally why Rram is a little bit more difficult, because we start using these wonky numbers instead of halves and whole numbers. Okay, so the only difference on this one is now instead of plugging in 0 or 0.5, I'm plugging in 0.25. And then my next one is 0.75, and then 1.25. Okay, so again, though, notice I still have 1, 2, 3, 4, 5, 6 heights for my 6 rectangles. Okay, and I'm still adding them all up. So I take all the heights and add them up. Do they still have the same base length? Why, yes. The base length for each one is still 0.5. And my area here is 14.9375, which is probably the most accurate, it definitely is the most accurate of both of them. Now, common misconception. You cannot just take, to get Mram, you can't take Lram and Rram and average them. It doesn't work that way. Okay? It theoretically should, but it doesn't always work that way, depending on the function. Okay? The steeper the function, the less it seems to work that way. Okay? It might be really close with these. Plus, why would you want to do that anyway? Why would you want to do 2 Lram and Rram to get Mram when you can just do the Mram in the first place? Why do 2 different rectangular approximations when you can just do 1? Okay, so there's really not, it's not that difficult. It just takes up a lot of time. Okay, so make sure that when you're doing this, that you're doing it accurately. The hardest part, again, is setting up, knowing which one you're doing and which values or where the rectangles are hitting. So please, when you do this, make sure that you're drawing a picture to help you out.